The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody, and welcome to today's ILTA webinar, Disaster Recovery in the Cloud. I'm Stephen Schock with Irene Manella, and I'll be serving as your moderator today. Our speakers today are Mark Hadfield, CEO for nScaled, and Mike Hamilton, who's the Director of Client Services for nScaled. Today's presentation will run about 45 to 60 minutes, and then we'll have time for Q&A. There is a question and answer box. If you could please type in questions that come up throughout the presentation, we will address those at the end. Before we start, please be aware that we are recording today's webinar and will post a link to our website under recording shortly after today's presentation. And finally, in order to see the PowerPoint slides in full screen mode, please click on the full screen button in the top right-hand portion of the PowerPoint slide. Now I'll turn over the webinar to Mark and Mike.
Thanks, Stephen. Hopefully everybody can hear me okay. And one final point, if you are listening on your computer and you find difficulty with the audio, you might want to call in on the phone, and that often helps. So let's get started. As Stephen said, my name is Mark Hadfield. I'm the CEO and founder of nScaled. And nScaled is a recovery in the cloud or disaster recovery, cloud disaster recovery company. And what we're going to talk about today are two pretty near and dear topics to a lot of people's hearts. One is a real-world case study. This happened with Hurricane Irene that recently rolled through and affected a number of our customers. And so we thought we'd highlight that, what went on in the beginning, during and after, and what we learned in protecting those customers during the hurricane. And then secondly, I'll hand over to Mike Hamilton, who has the dubious advantage of having been both a customer and an employee of nScaled. So he's seen both sides of this business, and that makes him pretty well suited to talk about it. But he's going to talk about today specifics on protecting Exchange 2010, which again is something that is on a lot of people's agenda as they roll into Exchange 2010. So let's get started. We're going to address this in bits, and I'm going to be quite brief. But before the storm, during the storm, after the storm, what happened with one specific client? I'm not going to give you the client name, but we will tell you about what specifically happened in the decision-making process, and then finally what we learned and what we can learn afterwards by this customer having invested in an effective recovery in the cloud solution. Before we dive into the specifics of the storm, I'd just like to give people an indication of what this typically looks like so you have some context. This is a typical nScaled installation. So what we do is we protect an existing data center that our customer has, which is typically in their office. It could, of course, be in a colo. It doesn't matter to us. We protect it with a local cloud appliance. So in this diagram, all these different local cloud appliances, one is in each data center of a specific client of ours, replicating over MPLS into what we call the remote cloud. And so you end up with a variety of recovery capabilities if you're an nScaled customer. You can recover locally, and you can recover in the remote cloud. And one key feature which we're going to talk about is the ability to test ahead of time, which was important with the hurricane. And it's all done through a web browser. As you can see on the right-hand side, you have complete control of this infrastructure, including the recovery capabilities with a web browser. So that said, let's move on to the actual case study itself. So, as I said, this is about a specific customer of nScaled based on the East Coast. They didn't have as many data centers as what I just indicated. In fact, they had only one data center protected and replicated into the nScaled remote cloud. So using what we call hybrid cloud, local plus remote, and protecting all systems with about a 60-minute RPO and about 15-minute RTO per server, tested ahead of time. When we do an implementation, we test each server for recoverability ahead of time and make sure it boots. Now, the one thing about hurricanes, unlike other disasters, like, for example, terrorist attacks, God forbid, but like hurricanes, you see them coming. So in this case, customers were able to test, and in fact, nScaled, in case of Hurricane Irene, did proactive testing. As we saw the hurricane rolling up the coastline, we contacted customers, and we did testing ourselves, retesting of protected systems But it also gives you gives the customer the ability to reconfirm responsibilities, and if the power goes out, who's going to call who? What if the phone doesn't work? So you really do have a bit of time to prepare, which is very helpful. All right. So so during the storm itself, after this testing, and again we did proactive testing, you know, the nScaled support team was on alert and was monitoring the situation. And because we have a local appliance in every customer account, we also have some local monitoring. We can tell if systems are replicating. We can tell certainly if the power is on, etc. So we have a pretty good view on what's going on in the data center, as do the IT folks who may be at home. You know, they're looking after their family. They have their own issues to deal with hurricanes rolling through. But through the web browser that I talked about earlier, they can also have a pretty good view as to what's going on in their data center and be ready to act should a disaster strike. Now, the good news with this particular customer is that there was no flooding enough to affect the data center of this particular customer. Unfortunately, there was some bad news, and that is part of the power grid was taken out. And we were the first to know about this when our locally provisioned appliance in their office lost power. And in fact, the whole building was down. I think it might have been more substantial than the building. At this point, the customer contacted our support team that was on standby, and this is something that Mike perhaps can chime in, because I think he was the one leading this conversation from our end. But you know, the questions that we asked, the one thing about disaster recovery, and certainly with the nScaled solution, is that you're not constrained to one set of actions, and it really depends on what is the scale and scope of the disaster. You know, is the power out indefinitely? Is the building destroyed? Is the building flooded? Is it a brief, or do you even know how long it's going to be out for? And those types of questions are going to affect the plan of action that you might. Can you comment on the specifics of that conversation that you had in this case?
Certainly, thanks, Mark. And basically, for this client, the discussion revolved around how long he thought he was going to be down. And so he was getting different answers. And initially, his answer was maybe a few hours. And then after a few hours, it was maybe a few more hours. And then after a few more hours, it was possibly as much as 2 or 3 days. And as that dialogue was going on with the customer in the background, we were talking them through, you know, well, how would you like to get started? And we actually started activating their primary service, our most important service, as soon as possible. When we knew something was going wrong and that they would have a service outage, and we did go off book, and that's not something that other DR providers are typically able to provide you with, is this ability to go off book. They're usually stuck to some kind of a run book. There's usually a very hard line in terms of how you're going to fail over. You're usually failing over to some kind of a colo or a less flexible facility, something very rigid that's been scripted, and you know, there's just not a lot of flexibility to fail over with. Whereas with our solution, and what impresses me so much about our solution is the fact that you can fail over one system or 2 systems or 3 systems or all of your systems, depending on how long you think the outage is going to be. And you have different options for failover. Maybe you want to fail over and plan for running several days in the cloud. Maybe you just want to plan to fail over for a couple. And we can go off book. We can offer you different solutions, different methods of failing over which system you're going to fail over. And in this customer's case, we ended up doing a lot of the work for them. Their IT staff was busy. They were taking care of their own issues, trying to make sure their family was safe, and so we actually followed their run book and followed their course of action that we worked out with them over the phone and did most of the work for them, which really is a relief on their staff, and it lets them know that their business continuity can continue to go on and be guaranteed even though their IT staff may not be available.
Okay, thanks, Mike. So sort of post-mortem, I mean, the net result for this customer was they were protected. They did fail over. They failed over for a period of time. I believe it was about 3 days. So yeah, 2-3 days, and then failed back. You know, during that time, they were able to focus on other priorities that they had. And unfortunately, because of the proactive testing, the initial testing, also the proactive testing, and the ability to test that's built into the system, in other words, the amount of testing that they could do didn't affect production systems. I mean, that's a really key thing when it comes to DR. We frequently talk to organizations that have DR, but one of their biggest problems is the ability to test, because if you have to take your production systems down in order to test, that makes things very difficult, and it is never a good time to take a production system down. So the fact that they could do that ahead of time gave them confidence. It certainly gave our IT team confidence, and certainly helped make it for a much smoother process in the actual outage. So that's key. So in terms of the finances, I mean, you can look at this different ways. You know, DR is one of these projects that you know, is always on the agenda and often gets pushed off the agenda, and people hope that it never happens, and in many cases it doesn't happen. But if it does happen, the cost is substantial. It can be catastrophic. That's why it's so critical. So in this specific case, the contract, this is a sort of medium-sized client to us. We're charging them $50,000 a year service fee. They've been our customer for a year, and their estimate was that avoiding 3 days of downtime avoided them $900,000 in lost revenue. So clearly a very, very compelling ROI in this case. As you look to justify DR expenses on your own side, the other way to look at it is to sort of combine different things under the one heading. You know, we actually have a saying, which we've done a couple of webinars, which is backup is dead. You know, backup is a portion of, it's a feature of recovery. What you really need is recovery. But in terms of justifying the investment, you can start to look at consolidating your costs for things like backup and maybe tapes and maybe manual processes, as well as the potential financial impact of a real disaster as you look to justify the cost. And often we can help a customer or prospect justify the cost in that way beyond just the unknown, the fear of the unknown. So with that, I'm going to hand over to Mike to talk a little bit more specifically and a little bit more technically for those that are technically oriented on the call about Exchange 2010 and how that specifically is protected in the nScaled cloud. And again, before I do that, I'd like to just remind you that if there are any questions for either of us, please feel free to type them into the Q&A box that you have window, and they'll be addressed towards the end. All right, thanks, Mike.
Thanks, Mark. So we're going to talk briefly about how to protect Exchange 2010 in the cloud. And on the agenda for this topic will be application-specific recovery. What is a DAG? Why is the DAG in a hybrid cloud such a great solution? What is the failover and failback process? And how do you scale up? So how do you make the how do you use the DAG solution in a large installation, for example? So one size doesn't fit all in terms of disaster recovery, and anybody who tells you differently really isn't paying attention to individual customer needs. Having done many implementations myself, it's clear that every time you encounter a new situation, you need to address it uniquely. You have to look at what's unique about the situation, and we have an approach that works really well for a lot of systems, and it works seamlessly. It's block-level mirroring. It's excellent. Does a great job. But for Exchange, Microsoft has gone and come up with a great high availability solution. And it's called a database availability group. The way that you make a decision about how you're going to do recovery has a lot to do with what's your recovery point objective. In other words, how much data can you lose? Can you lose 30 minutes? Can you lose 5 minutes? Can you lose 30 seconds? What can your organization afford to lose? And another one is the recovery time objective, or RTO. How long does it take you to get back up and running? And the application architecture for Exchange 2010 actually gives us a nice way to deal with this. Your application architecture really tells you how you're going to do the recovery and what's the fastest way. If you've got an application that's particularly rigid, maybe block-level mirroring is the best way to go. But in the case of Exchange 2010, Microsoft has come up with a really elegant way of giving you both local recovery capability as well as recovery in the cloud capability. And using a provider like nScaled, using nScaled specifically, gives you a great environment which you can be sure that your data is yours, that, you know, it's just like having your own private co-location facility, but without the expense of a colo or the trouble of building it. So a DAG is a database availability group. It's a feature built into Microsoft Exchange Server 2010. Basically, it allows you to have up to 16 mailbox databases per database availability group that have replication built into them. So for example, if you have multiple DAG servers that are a member of the same database availability group, you can replicate the mailboxes between database servers, and it's built into the solution. It happens in real time. It's very quick. The recovery point objective is minutes typically. The architecture provides protection at the database level, at the server level, and the site level, and any server in a DAG can host a copy of a mail base from any other server in a DAG. So locally, if you build a database availability group locally, just in your own data center, what you have is high availability. It's essentially the same thing as a cluster. You've got the ability to recover locally in case one server fails. But the neat thing about a DAG, and what's really a nice feature of it, is that you can take one of those members or more of those members off-site and create a DR solution as well. So using the same solution for high availability in a DR situation. And what it basically does is it gives you that skill set that you already have in your Exchange administrator or in the managed service provider that you use, providing you with that, your Exchange infrastructure, to use that skill set to have DR without having to do a different solution and have a different knowledge set for DR. And to give you an idea of how the basic architecture works, on the left we have the customer data center. They have 2 mailbox servers and various CAS and hub transport servers and an AD server. And you can see that the green database on the left there is database 1. It has its set of mailboxes. On the right mailbox server within the customer data center, database 2 is primary on that server. And then each local server has a copy of the other one's databases as well, which in turn contains the mailboxes. Then adding the nScaled cloud, we also have a DAG member over there that has passive copies of both of the servers. So both of the databases that are housed locally in your data center operate as passive copies in the cloud, and continuously there's replication going on in between. One of the features of the nScaled cloud is that we have an Active Directory server running in your hybrid cloud environment. This is private to you. We act just like we're a colocation provider, a separate data center just for you, again, without all the cost and complexity of setting that up yourself. And that AD server basically defines the subnets in your nScaled cloud environment as an additional site in your Active Directory sites and services. And within Exchange itself, that also identifies it as a DAG server that's off-site. And so that gives you the ability to sort of have the mailbox server that's in the cloud fit into your Active Directory topology and into your Exchange topology automatically by the architecture and by having it running in our environment. So let's say that a single server fails at your site. One of your servers has gone down and it's not functioning any longer. You have that cluster capability. The local server fails and you've still got the other server. For the sake of latency or just, you know, quick response time, you might just want to fail over locally. It's not to say that you couldn't fail over the failed server to the cloud, but you may just want to fail over locally, and that covers you for your local site. And if you've planned your Exchange 2010 architecture and you've only done a local DAG, this is what you would see. You wouldn't have the nScaled cloud on one side. You would just be able to recover from one server failing locally. But in this case, we've still got passive replication. We've got replication going. We've got the passive databases in the cloud. And so you've still got that additional copy going off-site in real time, even though you failed over locally to your other Exchange, to one of the other nodes in the cluster. But now let's say you've lost the entire site. So maybe you didn't lose the whole data center. Maybe for whatever reason something happened, some bad driver upgrade or something took out the hardware that you had for your Exchange cluster locally, and you only lost the cluster, but you still got your Active Directory and you've still got your hub transport and CAS locally. You can still fail over to the cloud and have your mailboxes reside there. The replication is very quick. It's going on in real time as mail messages are coming in, as calendar events are being created, and they're all being replicated into the cloud. And you can recover from your local site failure by just running your mailbox server in the cloud. Or if you lost your CAS and hub transport servers locally, you could have servers waiting in the cloud running as live primaries. We can provide you with an internet connection that would give you connectivity to the internet and allow mail to come in from that side instead. You could redirect your spam solution, your anti-spam, or your mail archiving solution to the cloud transport servers instead of your local servers. You'd be back up and running in a matter of minutes. So how does the failover and failback process work? So for the failover side, you're going to first update your DNS records for the Exchange 2010 services. You're going to change your SMTP MX records, any HTTP or CAS records, auto-discover, those type of services get changed first. And again, if you've got an anti-spam solution or a message archiving solution that you have in front of your mail servers, then you're going to need to add the failed over site to that list and make that primary, and then your mail will start traveling to the cloud environment instead of to your local environment. You would also update, the next step would be to update Active Directory at all of the data centers to mark the DAG as stopped at the failed site. So again, as a part of the AD sites and services component of this, the failed site is offline. You need to let the Active Directory know that that site's offline and that the cloud environment is going to become the main site. You'd stop the cluster service on all nodes in the failed site. That's if you have access to the servers, obviously. Update Active Directory at all of the data centers and mark the DAG as active in the cloud. And then ensure that the passive copies of the database hosts by the servers in the nScaled cloud are mounted and activated. Which this is all just a series of quick PowerShell commands, actually, that make this work very quickly. And then once you've completed that step, the clients begin connecting to nScaled instead of your local data center. And one of the keys to this architecture is that if you did still have your CAS Hub servers running locally, any open sessions that somebody has, whether they're using OWA or Outlook, there would be some interruption in their active session because there's no session awareness built into the CAS server role. So they might have a little blip while you fail over, but once they reassociate to the cloud CAS server, or if your CAS server has to be repointed to the cloud, then it's pretty quick, basically, once they do that. So they may not be exactly where they left off, but they're still working. For failback, what we're going to do is you'd have to restart the DAG at the primary site. So your servers have come back online, and maybe they're completely taken out and you lost all of your data, and now you need to replicate it back. Well, once you re-add the DAG server, the local servers back into the database availability group, the replication will start going from the cloud back into your environment. You can monitor this. You can see how close it is to being caught up. And once it's updated and the DAG replication has caught up, your mailboxes are now back to the original data center. You would dismount the databases in the cloud, make sure to free the client connections, and start the redirection process, basically. And the last step, of course, would be to update your DNS records again to point back to your original data center, and you'd be back to where you started with a minimal amount of effort. And like I said, most of this is done through PowerShell commands that can be easily documented in advance and tested, basically. So it's a really, really elegant solution all the way around. So how does this solution scale up? How do we make this bigger? Let's say that you're a really large organization and you're saying, well, I have multiple sites. How do I do that? How do I protect multiple sites with Exchange 2010 database availability groups? How do I make sure that this scales? And looking at the diagram here, we have a site in Honolulu, a site in Chicago, a site in Boston, and a site in San Francisco, and then your nScaled cloud environment. Each site can have its own database availability group. So, for example, Honolulu only has one server in the database availability group on that site, but then Honolulu also has another database availability group member in the cloud. Chicago has two servers locally, but it has one database server in the cloud. San Francisco, let's just say I did this to show sort of a larger site. San Francisco might have two locally and two in the cloud, and then the Boston Center only has, again, two locally and one in the cloud, towards the similar architecture we discussed earlier. Now, the key here is that each of the servers that you see indicated by the colors in the cloud, each of those database availability groups is a separate group for each site. So even though nScaled is a single site, it's your single hybrid cloud solution for the Exchange 2010 replication, there are multiple database availability groups that are handling replication between your remote sites and the nScaled cloud. And this gives you the ability to organize your mail and organize your protection based on if a single site fails, and have your mail basically spread out across multiple servers, but giving you all of the resilience that you need. And then we can also give you, for example, we have a load balancer technology that you can use if you'd like to load balance for your CAS servers in the cloud. We can basically take over mail transport for you in case you fail completely, or you could route your mail transport through the MPLS cloud. If you don't have any MPLS network, you can have multiple VPN connections into your cloud environment to give you that virtual private connection. So it's a really elegant solution and a great way to deliver high availability email and Exchange services to your end users.
Okay, thanks very much, Mike. A couple of things, just a couple extra comments on that. Strike me just listening to Mike talk there is, what he perceives to be pretty straightforward is still relatively technically complex. There's things to think about, and in the midst of the power being out and people calling and complaining, and that was just there can be a lot of confusion, and so it's good to test ahead of time. It's good to document ahead of time. It's also good to have a team that's ready to stand by you in the case of a disaster, particularly if you're short-staffed or under-resourced, to help you through these steps. Second thing that struck me is that's just a single application. When we're talking about 5 or 6 different core applications and potentially many, many more if it's a more catastrophic disaster, there's a lot of different considerations. And finally, it's not always cut and dry as to exactly what you want to fail over. It might be a much more limited scale. This is something that we frequently see. A hurricane is one thing because it typically takes out the data center, but what we see very frequently on a sort of weekly basis is much more minor events, accidental deletions or corruptions, virus attacks. One of our customers, for example, was attacked by a virus where the virus didn't delete, it actually renamed a substantial portion of their files and then demanded a ransom to actually, I mean, I laugh, but it's not funny at all. It was a very, very serious issue. Demanded a small ransom that was completely out of proportion to the scale of the disruption to the organization. They didn't pay the ransom. They recovered from a 15-minute snapshot that had been taken just prior. So my point is that there's many different ways to recover if you have a comprehensive system in place. And when disasters roll by, you really do need to be prepared. Otherwise, you're going to be left short. So with that, I think what we'd like to do is turn over to some Q&A, and we are happy to answer questions if you type them into the Q&A box. We do have a couple already. So I'll just read them out, and we can go. So the first question is for Mike, I guess, and the question is, do you support tools such as SRM to help with failover and failback processes?
So SRM is basically a solution that's built around and dependent upon your SAN vendor having some kind of SAN-based replication on both sides. That's one of the core components of SRM from VMware. In case if you're not familiar with SRM, it's VMware Site Recovery Manager. And the key, again, is that Site Recovery Manager requires that your SAN is doing some kind of replication from your site to the remote site, which means that all the data you're trying to protect needs to be on that SAN, or else that's not going to cover you. Our solution uses block-level mirroring at the guest level, so it's at the actual operating system level, which means that you can get site-level replication. You can replicate any server, regardless of what type of storage it's using. If it's using iSCSI, if it's using Fiber Channel, if it's direct attached storage, we can replicate those at a block level to the local cloud appliance and into the cloud environment, no matter what the source is, and then activate those servers, whether they started out as physical servers or virtual machines, in the cloud environment in the event of a disaster. So the short answer is we don't integrate with SRM, and that's largely because it's so SAN dependent and so dependent on a single SAN manufacturer that we would have to have the similar hardware in both sides, which really wouldn't allow us to serve as wide of a variety of customers and as wide of a variety of needs as we can serve with our solution.
Yeah, and just a further comment on that is that, we're not really wedded to any particular method. We're constantly researching and looking at different methods and also quite open to support different methods. What you get with the nScaled solution is you get a cloud data center. That's at its barest level what it is. And we have, expertise in certain methods, and we're constantly testing and integrating them into the platform. But as technology evolves, for example, VMware is doing some new stuff that's great. We constantly monitor that, and if something better comes along, like, for example, Exchange 2010, if the native protection of Exchange 2010 is very, very good, we're happy to support that as well. So it's not necessarily a one-size-fits-all. I think that's important, is to have that flexibility in your DR plan. All right, so next question is, for your block level, just excuse me one second, let's expand this. Next question is, for your block level replication, there's a driver to be installed on every protected host. I guess that's for Mike again. Is there a driver to be installed on every protected host in block level replication?
Yes, there is. So we do use an agent on every host, and it's developed by a company called Falcon Store, and it does block level mirroring. So every write operation encountered by the kernel is written also to the local cloud appliance. And the key to understand here is that it's latency dependent, which is why it's a local. It's a local cloud appliance, but it gives you the 3 copies of data. So you have your running copy, you have the mirror copy on our local cloud appliance, and then you have the cloud copy, which is off-site. The agent interferes minimally with kernel operations because it's really just block-level mirroring. Rather than interfering with the application, what it does is it queues as needed to make sure that the application functionality isn't harmed while still giving you the block-level mirroring with the local cloud appliance. And it's actually the most efficient block-level mirroring technology I've ever seen. The way that the agent handles snapshots is incredibly efficient. It does a great job of keeping the size of the snapshots to an absolute minimum, and yet giving you this very quick ability to revert to the snapshot and spin up an active machine based on the latest timestamp or the timestamp that happened before a virus, for example. So it's just an awesome solution.
And Mike, another question here is, here it is, what is your price model? Is it per agent, license, amount of data, and does the amount of data that you're replicating play into it? I guess I can address that one. Our price model is pretty much as stated. It's based not on per agent, but based on a number of factors. One is the number of machines protected. The other one is the total volume of data in terabytes. And obviously, we also have we haven't really gone into the specifics of how we lay out the architecture, but we have something called the data protection lifecycle, where we have a primary server. We have a continuity mode, which is a local copy available immediate for local recovery. Then we have a disaster recovery copy, and then finally, for customers that want it, we have an archive retention, long-term historical retention facility. So all of that, does factor into the total volume of data that we store, and in terms of pricing, that's how we charge it. It's just based upon the total volume of data stored. The other factors that affect data volume is the rate of change, the historical retention of snapshots. So that those factors come into it, and obviously that differs from customer to customer and system to system. So another question, Mike, is do people tend to take an enterprise approach to disaster recovery, or do they start with one application and move on to other applications, or only focus on some applications?
I think given the nature, most of our customers actually focus on an application. And it's easy. The smaller customers usually focus on the enterprise. As a matter of fact, it's actually easier for them to focus on the enterprise. And then larger customers tend to start with an application, which is usually the one that has the biggest business need to be protected and highly available in a disaster. For some companies, that might be Exchange. For other companies, it might be their document management system, or it might be their SharePoint installation. And the key is to choose that. It's actually usually really easy to make a business case for it. You can usually ask someone in charge of the business side of your organization, what is the system that we could be down with the least amount of time, and that's the one you're going to pick. And you can start with that, and we have some options in terms of pricing that really make it easy to get started right away. You can start now, even if you hadn't budgeted for it this year, typically in most cases, and get started right away with a single application. And then you've got this room to grow, because once you've got the cloud environment set up for you, you've got the local cloud appliance, and you've already got data replicating. It's really easy to add more data, just protect more servers. It's very simple to engage our professional services to help you with that, or you can even just let us know that you want to protect another server and move in there. We can have it certified, tested for you, ready to go in the event of a disaster. So it's simple to start. It's simple to scale, and I think that if you're having any hesitance about whether or not you should be protecting something, starting small is a great way to go. Picking your most critical application is a great way to go, and then moving on from there, you can add more and more systems to the project. As Mark said earlier, DR is something that tends to sit on people's budget list or their project list, or something that they want to do down the road, but there's usually one of two limiting factors. Most of the time, the most limiting factor is their actual IT resources. They just don't have enough staffing to do it. And even though they may have the talent in-house to do it, they may have the people with the skills to bring their data offsite and activate it. Two questions you have to ask yourself in a real disaster planning is the resource that's the most knowledgeable about the system going to be available in the event of a disaster? Are they going to actually be able to have a network access and be able to get to the resources they need? And the second question you have to ask is it simple enough for other people to do? And is it cost effective over the long haul?
Yes, that's the other thing about system by system. What we typically see, at least with customers that are sort of less than 10,000 people and have some budget constraints, they do take a piecemeal approach to DR, and that means that they use one application protected with one service, another different way. Then they've got some tape library, then they've got data domain in there, and then maybe they've got double take with a core system. And so what tends to happen is a couple of things. One, they have a complex environment, and as you can already see, when things go wrong, the more different methodologies in place and different systems with different vendors, even potentially, the more points of complexity that you have to deal with and think about. So by taking an enterprise-wide, you might not start enterprise-wide, but at least taking an enterprise view on things you can then start to standardize recovery and protection across the entire system. And ultimately, there's a reduction in complexity and in cost. And there's an ability to move the IT team on to focus on things that are more strategic. So we do sort of advocate that, but starting small is the way to build on it, because you can socialize it within the organization. That's the other thing. I mean, if you look at the perception of cloud services within business users, it's uniformly positive, except for when it comes to risk. And so these things do need to be socialized into the organization to allow people to become comfortable with them overall. And the way to do that is to start small. Maybe start with just DR and just some core systems, and allow people to become used to the idea of using a service provider to do this function.
Yeah, and if I can add one thing to that discussion as well, is that our Cloud Console actually simplifies all of the underlying architecture that we use. So it doesn't take a huge skill set to activate your server in the event of a disaster. It's very, very simple. And this allows you to have other resources that are available within your company in the event of a disaster available to help with the activation or to make a decision as to whether or not they want to activate, as well as just contacting our support hotline and saying, for example, a CFO could contact our support hotline and say, hey, I'm in the middle of a disaster here, can you help me out? And our support team can help out, or your IT staff can help out. We take all of the complexities of the underlying architecture and we abstract them into this great user interface that makes it so simple for anybody to activate their disaster recovery scenario and be active and ready and running in no time, because we've tested it, because we've walked through it, because we've certified the servers that are being protected.
Okay, so I think that we're sort of coming to the end of the questions here. Stephen, do you want to sort of wrap things up?
Well, if anybody does have more questions, I'd love for you to get them out there. I do want to remind you that a copy of the PowerPoint document and a link to the recording of the webinar will be on our website in a few days. Look under the recordings and webinar recording on iltanet.org.
Actually, Stephen, there's a couple more questions that have come in, so let's address
Perfect.
those while we're on the call. So the question from Andy is, what about companies with clients that demand absolute confidentiality of their data? Great question, Andy. And I would say, which companies out there do not demand absolute confidentiality of their data? It's funny. We actually, when we started this business, we used to sort of focus on the market segment of what we called risk intolerant customers. People that are very intolerant of risk. But if you actually ask people, what is their tolerance for risk? Uniformly, the answer is 0, or very, very small. Doesn't matter where they are. It's critical. I mean, we sit on very, very confidential data, and we are acutely aware of it. So security and confidentiality is designed into the system from many, many different angles. And one of the differences when you talk about cloud generally with nScaled is that this is not cloud as in it's somewhere out there in the cloud and I can't tell you anything about it. This is more like having your own colo. So under NDA, we will expose all of the secrets around security, including, certainly physical location of data, machines, methodologies, technologies in place like intrusion detection systems. So whatever you need to know can be exposed to your IT team, and you can make your own assessment. And ultimately, that's how you would protect your own environment if it was owned and managed by you, and this is no different. The other thing is, under the hood, it doesn't look very different to what you have running in your data center already. It's a VMware environment. It's running in a top-tier colo, and it's connected over VPN or MPLS lines. I mean, all of these technologies are very familiar to most IT people, and they tend to be comfortable with it. Second question is, can you talk about how you protect client data? What mechanisms do you have in place to ensure that the data is separate from client to client? So, the answer to that is along similar lines. Confidentiality and security is from within as well as from without. And so I can't really give you that much detail on this call, but suffice to say that we have a lot of mechanisms in place, technical. This is a multi-tenant environment, I'll say, and that's how you get the cost effectiveness out of it. This is not dedicated. Dedicated is very expensive. Multi-tenant and the disaster recovery use case is the way to go when you look at cost effectiveness. So we have, a very significant compute bank, which is available to do compute functions, and we have very significant storage bank in every data center, which is multi-tenant. We can also provide dedicated storage. So, if your organization was particularly concerned about shared storage, we can provide dedicated storage. Obviously, it depends. There's a cost factor, and it depends on the quantity of data. It has to make sense from every perspective. But those things can certainly be addressed. But for most organizations, once they dive under the cover and look at the details of what's going on technically, and then they also look at other risk factors, like, for example, what is the actual legality of if there is a security breach? I mean, what does nScaled do if there's a hacker attack? What is the specifics that happen? All those things are addressed contractually. So we really do focus on addressing risks from a number of different perspectives. I think our client list, which includes law firms, major law firms, financial services organizations, healthcare with PCI and HIPAA requirements, indicates that we do a good job there. So I think, Stephen, let's wrap up, unless there's any other questions at this point.
I had a quick question for you guys. As a solution provider, have you guys looked at data in motion or data in use? For us, we're a large litigation firm. We have a lot of data that sits stagnant but needs to be online. Have you guys started addressing that in your model as to how to place application or data that's readily available versus archive?
Yeah, so you're talking more about sort of, when data gets old, how do you move it into more cost-effective storage if it's less frequently accessed, but still keeping it accessible? Is that what you're referring to?
That's correct.
Yeah, so that's something that we address. As I said, we have this notion of the data protection lifecycle. So, with our system, what you do is you would set up policies, and this is more pertains to the way snapshots are taken. And the policy may be, current data is stored locally in production systems, and by the way, locally might represent high performance and high cost local storage. But as data ages, it's continually moved into second and third tier storage, culminating in a completely off-premise location on deduplicated long-term disk-based storage that is still accessible, but it's not accessed frequently. So we certainly do address that. We don't do it at the application level. In other words, we don't have an agent that's sitting in the Exchange server or the DMS moving documents that are less frequently accessed into different storage. But those types of applications do exist, and we can coexist with them. So, for example, we can make third-tier storage that is deduplicated off-premise available, and you can set up a storage location, and you can point a different application-based agent that is doing that type of analysis to use that as their repository for that long-term storage. So, this is a full data center capability. It's off-premise. It has a variety of features. And once you have connected your network to it, it's there to be used for whatever reason. It could be for DR, could be for test and dev. We have customers that need short-term capacity to do testing, for example. It could be to run some production systems. Maybe you've got a new application that you want to push out into the cloud because you just don't want to invest in physical hardware. It's an elastic resource that's available for whatever reason. And one of them is, obviously, data is one of the big drivers. Data is growing, and the place to put it is on everybody's agenda. So that's certainly one of the drivers.
Excellent. Well, I want to remind everybody quickly, shortly after the webinar, you will receive a request for you to evaluate today's webinar. These are very important to ILTA and will help us continue to provide quality and timely educational opportunities to our members. So I guess we'll wrap up now. Again, I want to thank our speakers, Mike and Mark, and I thank you for bringing us some good information.
Thank you, Stephen. And thanks, everyone, for joining today.
Absolutely.
Okay, everyone, keep an eye out on